2.7 is different than 2.6, where we're not necessarily translating directly these problems. We're going to see these in more word-based problems, kind of like we did with that temperature problem. There we go, solving word problems. There's not really a formal um, strategy for solving word problems. But, I mean, we got some recommendations right here, right? Like, you'll have to, a lot of times, just like those problems in 2.6, you have to read and reread these problems. You just have to. I mean, to really understand it, like if you have this stuff down, that's great. But a lot of students don't, and it takes a long time. A lot of that time is spent reading and rereading the problem. Again, you want to kind of figure out what operations you're using and where they go with in relationship to the numbers. Sometimes a drawing, like drawing a picture or a diagram, is helpful. That's true. In some cases, it's not. It may not be as helpful, but again, that's something you're going to have to decide. I recommend it when you can, though, and we'll see some examples like that. You have to consider what conditions are given. Like if it says that the length of a rectangle is 5 more than the width, when you figure out your answer, you need to make sure that it's still true, that whatever length you get is 5 more than the width. Okay, so some of these will present several expressions or even equations that we have to be able to work with and make sure that they're all true in the end. Otherwise, if any of them are not true, then it's just not the correct answer. Another thing that will help you with solving word problems is figuring out what it's asking. What is the actual question? Because sometimes, like in that rectangle example, right? The length is 5 more than the width. They may say, well, what is the width? Okay, in that case, you don't really need to solve for the length. You only really need to solve for the width. Okay, now that's kind of a minor thing, but this happens from time to time, especially in 980 and 1010, where we ask questions and students get caught up in the math so much that they forget what question was being asked. So they end up solving the wrong question. So keep that in mind. Make sure, and that's part of reading and rereading the problem is you need to make sure you know and continue to keep focused on what it is actually asking you to solve. Always check your work. Um, in most of my classes, only about 5% of students will check their work. And in a class of about 20 like this, what's our attendance today? Right now we got 14 people. I'm looking at maybe one student that is willing to always check their work. That's a key component for awesome problem solvers. And again, if you can keep that in mind and always check your work, man, you go places. You're going to go places. The guess and test method is valid. But again, you need to make sure in the end that you're always checking to make sure that your conditions are true, or whatever values you found make all of the conditions or equations true. So guessing alone is no good. It's like, well, I just think it's 8. All right, that's great, man. I mean, there's an infinite number of numbers out there, so your chances are pretty much zero if you're getting a straight guess on some of these questions, especially when we get into decimals and fractions. So don't guess alone. Yeah, the guessing, the main thing about the guess and test is the testing part, right? So, and I can see if I can demonstrate it on this. So there's a few different types of guess and tests. I mean, there's random guess and test. There's I forget the second one, but the main one we want is inferential. So you're looking at the information they give you, making an educated guess, and then if it's incorrect, then you make usually minor adjustments. I mean, if you need big adjustments, then you make it, but you make adjustments according to what results that you get until you find a situation or a guess that works with all of the conditions they give you. So on this one, a piece of lumber 21 feet long is cut into 2 pieces. The longer piece is 7 feet longer than the short piece. Find the length of the short piece of lumber. Now, I'm not very good at drawing lumber, but I can draw lumber like this. And for me, this is the original piece of lumber. And how long is it? 21 feet, right? Excuse me. Now, it says the longer piece is 7 feet longer than the shorter piece. So we should end up something like this. That would be my long piece. This is my short piece. Kind of crooked, but whatever. So green is my long piece, purple's my short piece. And what the heck, all right, it did. Now, here's my two conditions, right? Is I know that my total amount of lumber should be 21 feet long. We're not taking into account how much is taken off from the saw, okay? If you want to be that technical, that's a little bit more complicated than we want to be right now. And then it says that the longer piece is 7 feet longer than the shorter piece, right? And the short piece, I'm just going to say, you know what? I don't know how long it is. It's just X. So the long piece is 7 feet longer than that. So it's the short piece, but 7 feet more, right? Now, here's what they want. Is they want you to say, well, you're going to take the long piece, which right now is X plus 7. Right, that's our long piece. You can put in parentheses. You don't have to. And we need to add the short piece. Now, if I took the long piece and the short piece and added them together, how long would that piece of lumber be? It'd be 21 feet long. So I can see both conditions, right? I can see the long piece, X plus 7. That's one condition. The other condition is both pieces need to add up to 21 feet. So at this point, I have an equation that I can solve. I don't need those parentheses because right now I can look to combine like terms. So there's 1x and there's another 1x. That's 2 x's. Then I got the plus 7 and this equals 21. So this is a two-step equation, where I need to zero out that plus 7. So I'm going to subtract 7 from both sides. So 2x, that would mean two short pieces, because x is the short piece, would be 14 feet. But I want just the short piece for now. So I just want one short piece, right? 1x. So I'll divide that by 2 to get one short piece, which is 7. So the short piece, right now I can see we just solved, is 7 feet long. But I also want the long piece, which is simply 7 feet longer than the short piece. So I'm going to add 7 to that one and get 14 feet. So there's my two answers. I got a short piece that's 7 feet long and a long piece that is 14 feet long. I need that part. So again, I'm just going to go back and check. And you notice I kind of went through the wording on that a few times. I didn't really reread all of it at one time or reread it. But I'm going to go back and just make sure that everything fits. Okay, so does this total 21 feet? Well, 7 plus 14 is 21. So that's our first condition. The second condition said that the longer piece is 7 feet longer than the short piece. Well, is 14 7 longer than 7? Yes, it is. So both of those are true. I got a 21 feet piece of lumber, and the longer piece is 7 feet longer than the shorter piece. So everything in the wording on this checks off, and it's all true. So I know that the two answers here that I have are correct. Now, we already know the two answers. Let's say that you used guess and test on this one. Again, it's not really recommended. We want you to use the equations just because most of this module is based on equations. But if you were to use just guess and test on this, the first thing I would probably do is just cut this in half. 21 divided by 2, 10 and a half, right? Well, I would say, well, what if one piece is 10 feet and the other one's 11 feet? So I know it's 21 feet, but now it's not 7 feet longer. And then I can continue to adjust those two numbers so that they're still 21 feet long, but I want to adjust them until they're 7 feet longer. So I would choose maybe 8 and, what would that be, 13? Well, now it's only 8 and 13, 5 feet longer, right? So then I would adjust it one more foot, 7 feet and 14 feet, and bam, I got my answer. Still 21 feet long, but the longer piece is 7 feet longer than the short piece, okay? All right, here we go. A rectangular field is 3 times as long as it is wide. If the perimeter of the field is 576 feet, what are the dimensions of the field? Well, it's rectangular, right? So we're just going to emphasize the rectangularness of the field. And usually the long side is the L, the length. And right here it says that the length is 3 times as long as the width. So if this is my length and this is my width, the length is the width, but 3 of those, 3 times the width. Now we know from perimeter it's like adding all 4 sides together, and this other length also would be 3 of the widths. So the perimeter is length plus width plus length plus width, and you could use 2 times L plus W. I like to see all 4 sides like this though. So I know my length. I could rewrite this. Again, it's just like we did in 2.1, but instead of replacing it with a number, I'm replacing it with a different letter set, okay, which is W in this case. So the lengths are 3 of these widths. So now my perimeter also, I know, is 576 feet. So I replace the P, perimeter, with 576. This equals 3 widths plus that original width, plus the length, which is the green, 3W, plus that last W right there. So this becomes an equation. And right here I'm looking just to solve it. And of course there's no distribution, but there is combining like terms, right? I got 3W, 1W, 3W, and 1W. When I combine all those W's, 3 plus 1 plus 3 plus 1, I get 8W, or 8 widths, would be the same as the perimeter of 576 feet. Now, in order to solve this for just 1W, right, I'll have to take the 8 and make it a 1 by dividing it by 8. So we'll use long division here. 576 divided by 8, that'd be 756. Made of 1, drop the 6, 16 twice. So that's 72. Now this is a word problem, so we're going to have to label that. The width, where am I going to write that? No, we'll write it here. Width is 72 feet. Now it says what are the dimensions of the field? So I don't want just the width, I also need the length. And over here we can see the length is 3 times the width, so I need the 3. I'm just going to replace the width with 72. So we'll do that length. I'll show that with multiplication. 72 times 3, so there's 6. 3 times 7 is 21. So the length is 216 feet. Now, we need to verify that all of the conditions they gave us are still true with these 2 measurements. So, is 216 3 times as long as 72? Yeah, we just confirmed that here. That's okay. And then the last thing we need to do is verify that the perimeter with these 2 measurements would still be 576. So 72 plus 216, that'd be 288. And then you could just multiply that by 2, which would be 576. So everything about this problem remained true even after we found the answer. So we know that the width is and the length that we found are correct. One of the first things we see on this one is that the bag has 59 marbles in the bag. So if I were to demonstrate this, not necessarily with a diagram, but just algebraically, I would say, so I'm using G for green and P for purple. If I took all these marbles and added them together, I should get the total of 59 marbles. Now, another thing it says is there are 11 more greens than purples. So that means if you took the purples and added 11, you'd see how many greens there are. Right? Because right there it's saying we know there's more greens than purple. So how many more? 11. Now, since the greens is purple plus 11, I can take this green and replace it with this expression, purple plus 11. Okay, now again, if I add the original set of purple marbles, then I would get 59. Now, what this does is it gives us an equation. Sorry, that looks like an H. It's P plus 11. This gives us an equation with only one variable, which is P. So from here, now that we only have one variable, P, I can combine those, 1P, 2P's. And then we got that plus 11 right there. And this equals 59. Now when I finish solving this equation, I will know how many purple marbles there are in the bag. So I'm going to zero out the 11, subtract 11 from both sides. So 2 sets of purple marbles would be the same as 48 marbles. But we don't want 2 sets, we only want 1 set, so I'm going to divide both these by 2. And the purple marbles, appears that there's 24 purple marbles. So 24 purple marbles, we'll just say 24 purples. And for the greens, there's 11 more than that. So I'm just going to add 11 to that. And that gives me 35 greens. Now again, these are my 2 answers right now. But I do want to check, just based on the information they gave us, right? So I'm going to go into this. I can see that there are supposed to be 59 marbles in the bag. Well, what's 24 plus 35? It's 59, so that checks off. The next thing I need to check, are there 11 more greens than purples? Well, 24 plus 11, we just verified, and that's 35. So that one also checks off. Those are the only 2 conditions they gave us in this problem. So it checks off, and we're good. One angle in a triangle has a measure that is 3 times as large as the smallest angle. The measure of the third angle is 40 degrees more than that of the smallest angle. Find the measure of the largest angle. Now, here's what they told us, though, is that the 2 angle conditions that they gave us are based on the small one. So I'm just going to say that x, there's a pen on this one, x equals the smallest angle. Smallest angle. And that's an angle symbol. I just don't want to write the word. Again, I'm a lazy math guy. But here's what it says, is it says one angle is 3 times as large as the smallest one. So this is just one of the angles. I don't know which one it is. It's 3 of these small angles. So that's one of them. Another angle is 40 degrees more than the smallest angle. So that would be the smallest angle, but it's going to be plus 40. Now that's 2 angles. It's a triangle, so there should be 3, which means that the final angle is actually the smallest angle. So there's these 3 angles. What we know about triangles, and if I remember right, it didn't tell us this information in the homework, which is kind of, I guess they kind of expect you to know, but triangles, all 3 angles add up to 180. So it's a condition that they didn't tell us, but it's always true anyways. So I got to take these 3 angles. I got the 3x. I also have the second angle, x plus 40. And then I do have the smallest angle of x. All I'm going to do is add these together, and it should give me 180. Now this is only going to tell me how big the smallest angle is. Remember that we have to keep in mind what it actually was asking for, and that's for the measure of the largest angle. Once I get the smallest angle, I can go back to these 3 expressions over here and plug in x, the smallest angle, in and see which one is the biggest. So this is just a regular equation, we're going to combine all the like terms, 3x, 4x, 5x. So there's 5x's, and then plus that 40 equals 180. Now I will subtract 40 to zero that out. So 5x now equals 140. Again, those 40 zeroed out. Then we'll finish by dividing by 5. Since we're in a hurry, we'll just go over this one. It should be 28. So the smallest angle is 28 degrees. We know that's not the largest angle, of course. But if I did this as this second angle is 28 plus 40, it would have been 68 degrees. If I did this, the first angle that they gave us, 3 times 28, let's see what that is. 28 times 3, there's a 4 and a 2, so there's 6, 7, 84. So for these three angles, I can see that the biggest one is 84 degrees. And that would have to be my answer for this problem. And again, I did label it in degrees. You could just write out degrees if you want. But 84 is definitely a bit bigger than 68. Now, we should just double check a couple things, right? So, we already know that 84 is 3 times the 28. And 68 is 28 plus 40, the smallest angle plus 40, which were the first two sentences that they gave us, right? But the last thing that we should check is to make sure that if I add all three of these angles, that it equals 180. So 84 plus 68, that'd be 152, plus 28 is 180. So that checks off as well. Jerry and Tom are, should that be Tom and Jerry, are running a relay race. Jerry runs twice as far as Tom. Together they run 27 miles. How far did each person run? Excuse me. So we got Jerry. Oh, we got Jerry. And we got Tom. J and T, right? When we add those two distances that they ran together, we should get 27 miles. But one thing that they told us was that Jerry, he's going to run twice as far as Tom. So instead of writing this with J for Jerry, I'm going to write it as 2 of Tom's distances. So now I got 2 Toms plus Tom equals 27, right? Well, again, combining like terms, 2 T's plus 1 T is going to be 3 T's. So 3 of Tom's distances is 27 miles. But for just regular Tom's miles, we're going to take that and divide it by 3 to make it 1 Tom. Tom's mileage is 9. So for the 27 miles, Tom is 9 miles. Now, Jerry should have ran twice as far as Tom. Well, if Tom ran 9 miles, we're going to take 2 of those for Jerry. 2 times 9 is 18. So for Jerry, we're going to get 18 miles here. So there's one answer, there's the other. But let's just double check again. So does 18 plus 9 equal the 27? Yes, it does. And is 18 2 times as far as 9? Yes, that is also true. So both conditions have been met, and we know this is correct. But for this one, a pizza delivery driver has a base salary of $10,000 annually. If the delivery driver earned a total of $32,140 for the year, how much was made from tips? So it's not asking, the percentage from tips. It's just asking how much from tips. So for this pizza delivery driver, right, you got their, annual amount, right? Let's just say annual. The annual amount that they make is based off of the base salary, but also tips. So we're going to add these together, and it told us the base salary is $10,000. So we'll replace that with 10,000, just like we did in 2.1. And then this year they made a total of $32,140. So when I add the tips to this T to the 10,000, I should get 32,140. Now, this is the equation, you guys, and all I got to do to solve it is to subtract 10,000 from both sides, which is going to make that, right, a 0. It's going to 0 that out, so subtract 10,000. Some of you guys don't even need the math for this. It's just, oh, I wrote that wrong. $22,140. So in tips, this delivery driver made $22,140. Again, don't forget to label that with the $sign, and I should have mentioned that for that last example. Make sure you label all the answers in these. If you're doing them on paper, on the homework, it should be labeled for you guys, so you shouldn't have to worry about it.